Welcome to this explainer. Okay, so today we're jumping straight into something that powers literally everything we use. But honestly, it's notoriously tricky to grasp. I mean, electricity is completely invisible. You don't see the power zooming through your phone charger, right? We just flip a switch and trust that it's going to work. But to really understand how our modern world functions, we kind of need a mental model. We need a way to visualize the unseen.
So, here's the big question. How can water, something so completely different from a glowing light bulb, actually help us understand invisible electricity? Well, we're going to bridge the gap between a physical plumbing system you can touch and observe and this totally abstract concept of electrical currents. And you know what? Once you borrow the mechanics of water, the whole mystery of circuits just clicks. It becomes incredibly clear and totally logical.
And that brings us to our roadmap for today. Check this out. It's a real science worksheet filled out by a German physics student. Right at the top, the title reads Vom Wasserkreislauf zum Stromkreis, which perfectly translates to from the water circuit to the electrical circuit. We're going to follow this student's exact step-by-step logic to decode how electricity really works.
All right, section 1, mapping the circuit, water versus power.
So right off the bat in exercise A, the student had to match up the physical parts of a water system to an electrical one. And getting this basic vocabulary down is absolutely crucial. Look at how beautifully simple this translation is. An electrical source, like a battery, that's literally just your pump attached to a tank. It creates the pressure. The electrical wires hidden inside your walls, those are just water pipes, hollow pathways for the flow. And finally, the appliance, your toaster, your TV, whatever, that's your water wheel. It just sits there waiting for the flow to rush past and spin it into action. Moving on to section 2, the invisible flow. What's moving?
Okay, so we've got our metaphorical pipes all mapped out, we've got our pump ready to go. But what is actually flowing inside them? In real plumbing, it's liquid water. But inside a solid copper wire? The student's handwritten answer for exercise B totally nails this. In German, they wrote, Im Stromkreis fließen elektrische Ladungen, meistens Elektronen, which translates to, in an electrical circuit, electrical charges flow, mostly electrons. This is a huge light bulb moment. Electricity isn't magic. It is the physical movement of actual microscopic things.
Yep, electrons. They are literally the water in our analogy. These invisible charges physically rush through the lines. Just like a massive river building up behind a dam and pushing forcefully down a stream, these electrons get shoved through the circuit, they travel down those copper pipes, slam into your appliance, and do the actual heavy lifting of spinning that proverbial water wheel before moving on.
Which brings us to section 3, inside the battery, driving the flow.
Now, water doesn't just magically flow on its own across a flat surface, right? You need pressure, you need something to force it through. To figure out the pump pushing these electrons, the students sketched this really clear diagram for exercise C. They drew the electrical source, the battery, as two separate tanks hooked up in a loop to a central box, which is our water wheel.
And the real genius is how they labeled those tanks. On the left side, we've got the minus pole, which the student notes has an electron surplus. It is packed to the brim with extra electrons. Over on the right is the plus pole, which has an electron shortage. It's basically empty. So the whole reason electricity flows is just this massive imbalance. The minus side has way too many electrons, the plus side has too few, and that creates this intense pressure, forcing the electrons to violently rush out, travel across the wires, spin the appliance, and finally reach the plus side to balance the whole system out.
So what happens if you install the battery the other way around? It's a great practical question from exercise D. I mean, we've all accidentally shoved an AA battery into a TV remote backwards at some point. Why doesn't it turn on? The student's answer here is perfectly simple. Die Richtung ändert sich, meaning the direction changes. Because you physically swapped the surplus tank and the shortage tank when you flipped the battery, that invisible river of electrons instantly reverses. It starts pumping from the exact opposite side. You know, this whole worksheet does such an amazing job of turning the mystery of electricity into a super logical plumbing system. But it leaves us with one really fascinating final thought. If flipping the battery reverses the flow of that invisible electron river, what does that actually mean for the water wheel it's powering? If you spin a gadget's internal mechanisms backwards, does it just do nothing? Or does it cause something entirely unexpected to happen to the devices we rely on every single day? Definitely something to chew on the next time you pop a battery into your favorite gear. Thanks for hanging out with me for this explainer, and keep questioning the invisible world around you.